Well, here we have our first question, and it's a pretty old question. It's basically from the year 1987. It says a soccer ball of mass 1.25 kilograms approaches a goalkeeper at 5 meters per second. He manages to kick it back at 5.5 meters per second. What I'd like to point out here is that you have a single mass in this object. It's a one mass object. And if you have a one mass object, what you need to remember is that for all single mass objects, the equation that we are normally going to end up using is the equation that deals with the impulse momentum theorem, which is F net delta T equals to delta P. And let's go ahead and answer the questions. Now, normally in these questions, you have a diagram. So I'm just going to say that let's draw ourselves a little. So let's assume this is our goalkeeper here. And this goalkeeper is going to have a ball that's going to be essentially kicked towards him. That ball is going to go towards him with a specific velocity, and that velocity that it's initially going towards him, it's 5.5 meters per second. So that there is your V initial, and this is your mass, which is 1.25.
So
After a while, yes.
is it not 5?
Sorry, it's 5. Thank you. So we have a 5 meters per second. He kicks it back in the opposite direction. So the same ball now goes backwards in the opposite direction there. And that's your final velocity, which is 5.5. Now, here's the first thing that many learners actually forget in questions like this here. In a question like this here, what they actually normally forget is that you need to actually assign a convention for your velocity direction. That means we're going to take the initial velocity to be positive. And if your direction has changed, then that final velocity must be a negative. Now, these pluses and minuses are what makes this particular aspect a bit tricky, because learners very, very often, they forget to actually assign the plus over there or the minus there. That's something that they completely forget about. Now, we need to remember that we're going to be assigning those pluses and minuses when we actually do the question. 1.1. Calculate the magnitude. Now, magnitude means we only give the size without any direction. So your magnitude of your initial momentum. Initial means the momentum of this object at the beginning. So that's going to be m multiplied by v initial. And that's going to be 1.25 multiplied by 5. 1.25 times 5, I think that's 6.25. Please don't forget your units here. It's kilograms meters per second. And because they said magnitude, we don't put a direction down. 1.2 says change in momentum. Now, change in momentum, which is also your impulse, is a vector quantity. And because it's a vector quantity, we need to remember that when we calculate this change in momentum over here, that change in momentum must have a direction. And we need to then take into account these pluses and minuses that we have over here. So 1.2, your change in momentum is going to be m into v final minus v initial, which is going to be 1.25. Your final velocity is minus 5.5 minus your initial velocity is just 5 minus, so 1.25 into minus 10.5 now. And you're going to have your change in momentum sorted out. So what I'd like to do is I'd like to just get my calculator out and just quickly show you how we're actually going to do this. So 1.25 multiplied by minus 10.5, and we are going to get minus 13.125. So if we go back, that's minus 13.125 kilogram meters per second. Now that minus means something. That minus means that it's opposite to the original direction of motion. Now, because they didn't specify the direction of motion at the beginning, don't put left or right in your answer. So your final answer must read 13.125 kilogram meters per second, and then the minus opposite to the original direction of motion. But any questions about that one?
I have a question about, before I forget, for 1.1, if you use the convention, just say minus 5 for the initial, would you have to put minus 5 into P is equal to M into VI and get a negative answer?
Yeah. But then if you took the initial to be a negative, the final would be a positive.
Okay.